All right, let's talk about why it's so important to have on-site data and photorealistic 3D models, including the trees and vegetation in the Pacific Northwest. So if we look here, this is a project for NWES, Northwest Electric and Solar. And because of the dense, tall, old vegetation tree canopies in this part of the country, it's critical to be able to model them correctly. And by flying the drone and creating this 3D model in Scanifly, you get photorealistic renderings of the property, the home and roof itself, but the surrounding trees and vegetation like you see here. And a fun little trick that you can do in Scanify, which is something that was super valuable to the team at NWES, is using our occluder tool to be able to simulate the removal or trimming of trees on the property, and to see the impact it would have on the system to help justify going solar. So you'll notice there are two south-facing arrays here. There was previously a giant tree here. So if we click on occluders, you'll notice this was put in place to simulate the removal or trimming of that tree and that vegetation. And you simply just place that into the 3D scene, and you can see there it chops away the tree. And you'll see the view sheds here rendering differently, and it updates in real time the shading impact of removing or trimming the tree. So now that that has been removed, you can go and simulate the shading. You'll notice that that south array is no longer impacted by the shading from that tree. And that alone, being able to simulate that with the customer, could have been the make or break moment to determine whether solar was even viable for this customer. So it's a really powerful tool, and it just goes to show the importance of going on site, flying the drone, getting that real-time on-site shading, getting that on-site data safely and quickly is the best way to design solar.